All right. And again here, A is greater than B. Okay, so if you're looking for your focus points, remember you're starting at your center, but you're going to the right and the left C number of units. Okay, so that's H plus or minus C, K. Okay, where again C squared is equal to A squared minus B squared. Okay, and the center is the same thing. That doesn't change. You don't have to write it again if you don't want to. Our center is just HK. Now your vertices, that's a number of units from the center, and you're going from left to right. Okay, that's going to be H plus or minus A, K. Okay, now your co-vertices on this one goes up and down. Okay, so that's H, K plus or minus B. All right, leave that up for a few more seconds. Then we'll go to the examples. Excuse me. Looks like everyone's done writing. Okay, so let's say, for example, if we're given the ellipse, say we have x plus 5 squared over 81 plus y minus 4 squared equals 1. What are the coordinates of the two? Uh-oh, about to write the over again. Of the two focus points, or the foci. So this one, the first thing you want to do is rewrite it so it kind of matches up your formula. Okay. Okay, so we have x plus 5, and instead of x plus 5, we make it x minus negative 5. So x minus negative 5 squared. And instead of 81, we'll just make it 9 squared. Plus, instead of y minus 4 squared, we're going to rewrite that as y minus 4 squared over 1 squared equals 1. Okay. So we know just from that, it's in the form x minus h squared over a squared plus y minus k squared over b squared equals 1. Okay. So So how do we know the a squared is under the x term and not the y term? Because a is always bigger than b. Remember, your major axis is always going to be longer than your minor axis. Okay, so we know just from this, our a is equal to 9, our b is equal to 1, our h is equal to -5, and our k is equal to 4. Okay, so we know it's stretched out horizontally. So this is for horizontal. Okay. Now, just the fact that we know it's horizontal lets us know which formula we're going to use for the focus points. Okay. For a horizontally stretched, there you go, ellipse, we know our focus point is going to equal h plus or minus c k. Okay, which works fine. We know what our h and our k is. We can figure that out from up there. So we know that's going to equal -5 plus or minus c 4, which means we can't go any further because we have to solve for c. Okay. And once we find c, we'll be all set. Move that up a little bit. Okay. So we know that c squared is a squared minus b squared. Or if you wanted to, you can just write it as c equals square root of a squared minus b squared. You don't have to worry about the plus or minus since you're not going to have a negative c value. Okay, so that's going to equal your a squared. That's the square root of 9 squared minus b squared. So that's the square root of 81 minus 1, which is square root of 80. Okay, so we know that c is equal to square root of 80, but we can simplify that one since 80 is 16 times 5. So square root of 16 times 5, and we can go ahead and just separate those. Square root of 16 times square root of 5, that just becomes 4, so c equals 4 square root of 5. Okay, so we have our c, which means all we have to do is plug it into that. So since we know that our focus point is -5 plus or minus c 4, if we replace that c, it's just going to equal -5 plus or minus 4 square root of 5. 4. Okay, where this is our x value, that's our y value. Okay, so if we just separate those, that means it's going to equal -5 plus 4 square root of 5, 4. And -5 minus 4 square root of 5, 4. Okay, so those would be your two focus points. All right, any questions on that one? All right, I'll leave that up for a few seconds. right, so let's say, for example, we are given the ellipse make sure. Let's say x minus 4 squared over 81 plus, let me make sure I'll use the other example because it kind of switches it up a little bit. So x minus 4, let's put that over 16. Plus y plus 1 squared over 81 equals 1. We want to find the two focus points. So just like before, we're going to go ahead and rewrite it. Okay, so we have our x minus 4 squared. And instead of 16, we're going to make that 4 squared. Plus y minus negative 1 squared. And instead of 81, we're going to make that 9 squared equals 1. So the one thing we can figure out from that is that it's in the form x minus h squared over b squared plus y minus k squared over a squared equals 1. Okay? And we know that because a is always bigger than b. So in this case, our a is equal to 9. But this is stretched vertically instead of horizontally like the last one. Our b is equal to 4. Our h is equal to 4. And our k is equal to negative 1. We can go ahead and just put a quick circle around those. Okay. Now to find the focus point, for vertically stretched ellipse, it's h, k, plus or minus c. So just like before, we might as well go ahead and solve for c first since we know we're going to need it. So c squared equals b squared minus a squared. Or c equals square root of b squared minus a squared. Oh, a squared minus b squared. Sorry about that. I don't know why I mixed those up. Okay, so we have 81 minus 16. Which is square root of 65. Okay, so you don't have any perfect squares you can pull out of that one, so it just stays as square root of 65. Okay, so that means focus points, which is h, k plus or minus c. Our h is equal to 4, so it's 4 plus or minus negative 1. Uh-oh, forgot to put that negative 1 first. So it should be negative 1 plus or minus square root of 65. Or you can just go ahead and separate them. be 4, negative 1 plus square root of 65, and 4, negative 1 minus square root of 65. Okay, so those are your two focus points. All right, any questions on that one? Okay, we'll do one more example, then we'll go to the hyperbolus. Right, so let's say this time we're given the ellipse x minus 4 squared over 81 plus y plus 4 squared over 16 equals 1. What are the vertices and covertices? Okay, so just like you did before, the first thing you want to do is rewrite to where it kind of looks like one of your formulas. Uh-oh, forgot to write rewrite. There we go. Okay, so the first thing you want to do is rewrite it. Okay, so we have x minus 4 squared over 9 squared plus y minus negative 4 squared over 4 squared equals 1, which lets us know that it's in x minus h squared over a squared plus y minus k squared over b squared equals 1 because a is greater than b. Close that up. Okay, so since you know a has to be bigger than b, that means our a is equal to 9, our b is equal to 4, our h is equal to 4, and our k is equal to negative 4. Okay, so just rewriting it lets us know all those little details. Okay. So we know that hk is equal to 4, negative 4. Remember, that's your center. Okay, so we know that right from the beginning. Okay. So we know that to find our vertices, remember this is horizontally stretched. For horizontally stretched, it's h plus or minus a k. Okay. So we know that a is equal to 9. Our h is 4, so that's 4 plus or minus 9 k. Okay, which means we just separated it. It's 4 plus 9 k. Oh, not k. Why am I putting k when I actually know k is negative 4? All right, so those should actually be negative 4, negative 4. Okay, so it's 4 plus 9, negative 4, and 4 minus 9, negative 4. Okay, so our two vertices is just going to equal 4 plus 9 is 13. 13, negative 4. And 4 minus 9 is negative 5. So negative 5, negative 4. Okay, so those are your vertices. Okay, now to find our co-vertices, that's H, K plus or minus B. Okay, so we know B is equal to 4. So our H is 4. So we have 4. And our K is negative 4. So that's negative 4 plus or minus our B, which is 4. Okay, so that's going to equal the points if we stretch that out. 4, negative 4 plus 4. And the point 4, negative 4 minus 4. Okay, which gives us our co-vertices of 4, and negative 4 plus 4 is 0, so we have the point 4, 0. And we have 4, negative 4 minus 4 is negative 8, so 4, negative 8. Okay, so those are our co-vertices. All right, any questions on that one? All right. Leave that up for a few more seconds. Then we'll go over the hyperbolas. All right, so if we have our hyperbolas, it's kind of like double parabolas. We'll look at the ones with horizontal horizontal vertices. Okay, so let's say if our parabolas kind of look like that. Okay, so we basically have two parabolas facing away from each other. Okay, so we know with our parabolas, we had a vertex, and we had a vertex. Okay, so in addition to each of them having a vertex, they each also have a focus point. Now, the only difference between a parabola and a hyperbola, other than being two of them, is that you have a distance between both of them that we'll call our center. Okay. Now, going through the center, if you notice with these, if they just keep going and going and going and going and going and going, it's actually kind of an imaginary line through the center that the hyperbolas will never cross. We actually went over those before. Those are your slant asymptotes. So these are your slant asymptotes. All right. Now we'll get to the actual formulas. Okay, so if we look at our actual formula, our formula for a horizontal hyperbola, actually let me erase this since it went down a little further, is x minus h squared over a squared minus y minus k squared over b squared equals 1. Okay, for the ellipse, it's plus, but for the hyperbola, it's minus. Okay. Now for this one, notice the x term, this term here is positive, and the a squared is under the h. And over a squared. Okay. You just want to notice that in comparison to the vertical hyperbola. Okay. Now if you wanted to find your focus points, remember your center, that's your HK. I'll move my arm in 1 second. Okay. Now to find your focus points, you're going to go H plus C and minus C. Okay. Okay. Where C is your distance from the center to your focus point. Distance from center to your focus point. Okay. Now C is not the same as it was for your ellipse. For C, C squared equals A squared plus B squared for hyperbolas. So it's a little bit different. It's subtraction when it's for a parabola. I mean for an ellipse. Okay. So if we look at our vertices, okay, your vertices is actually H plus or minus A, K. Where A is equal to the distance from the vertex to the center. Open. Actually, for this one, just going to add a little bit more. So we know C squared equals A squared plus B squared. But B squared, if you subtract A to both sides, B is equal to the square root of C squared minus A squared. So that actually is going to come in handy also.